Hi, we're Group 16. I'm Brett Stevens.
I'm Paul Larson.
I'm Ryan Beard.
And we developed the Automated Home Brewing System.
Hi, I'm Ryan Beard, and this is our actual Automated Home Brewing System prototype. The Automated Home Brewing System allows home brewers to take the time-intensive process of brewing and reduce the actual user time on the system. It automates wort boiling, cooling, fermentation, and ingredient insertion. The system is customizable in that the time the ingredients are dropped are customizable, and temperature in both the wort and the fermentation stages is customizable. It is a gravity-fed system with ingredients dropping into the wort going through cooling, and cooling going into fermentation, and it will sit into fermentation for about 2 weeks, where at the end of that time it will be ready for bottling.
Alright, the Automated Home Brewing System top-level design was set up basically in parallel with how our system actually operates. So about halfway down we start with the ingredient insertion. The ingredient insertion flows into the wort mechanical. The wort mechanical goes to the valve goes to the cooling stage, and the cooling stage ends in the fermentation mechanical. That's set up just like we have it in our system, so the flow of our block diagram matches how it would be if you're looking at the physical prototype. Each element in our block diagram is controlled by an electric component and a power component. So the overall power takes 120 volts AC input and controls the wort electric relays and the fermentation relays, as well as the control block. The control block is run by a microcontroller. There are encoders and buttons that are used to interface, and the fermentation electric provides a feedback loop to the control block with temperature.
Hi, I'm Paul Larson, and this is the demonstration of our prototype. Basically, we have code set up that will emulate the whole process within a minute or two. So I'm going to go ahead and hit start. Reach it. Alright, so these lights right here that just came on show that it's boiling. That means the temperature inside that pot is not hot enough, so it's trying to heat up the water. We have a temperature sensor right back here that we stick into the pot to measure the temperature. Right there, that was the first of our ingredient insertion. So after it's been boiling for a while, it reaches a boil. It will turn that, drop some ingredients in. That was the second one. It's controlled by a servo, and we have a read switch on there also, which will show if our positioning is lined up and everything fell in correctly. And then what's coming up next is the valve is going to open for our cooling stage, which is in here. Basically, it'll insert the ingredients, and then it'll reach a desired time you want it to boil for. Then this valve will kick on, and that will drain through the cooling stage there, which is just cold water and about 26 feet of copper coil. Right there you can hear the valve pop on, the valve lights on. That'll go for about 45 minutes to an hour, depending what you want to set it as. And once it's done, the valve will actually kick off. That means all of the beer, which it just did, all of the fresh beer will be down in the bucket down there. And then that's where it'll sit for about 2 weeks. You'll see this light, this bottom light right here, you'll see that kick on and off if the temperature gets too cold, because we have a heat blanket down there which will raise the temperature if it gets too cold. And we also have, like this temperature sensor, we have another one in there to measure the temperature of the beer inside the bucket. And that's basically the gist of it.
I'm Brett Stevens. This is the wort mechanical stage, one of the portions that I was responsible for. This was actually one of our unique designs. not really by choice, but anyway, this is actually controlled by a 240 volt AC power. It's an internal water heating element that's typically used on a house. And below that is a thermal well for the housing unit for our temperature sensor, and there's also a false bottom. What's unique about this design is with the heating element in the center of the pot, it actually heats the top half first, and once that's at a rolling boil, the rolling boil actually creates circulation and heats up from the bottom. And this is actually good because once the hops and the ingredients are inserted, that continuous boil creates the mixture in the wort that we want.
Okay, I'm going to talk quickly about the ingredient insertion and our solenoid valve here. Our ingredient insertion uses a servo motor that takes a pulse width modulated signal. It's not true pulse width modulation in the fact that it reads the average voltage. It actually is a 50 hertz signal in which the length of the pulse determines the position of the servo. So this is a 180 degree servo, about a 10% duty ratio. So 10% pulse width is about 0 degrees, and then about 90% duty ratio, or a 90% pulse width, is about 180 degrees. Our valve here takes a 12 volt signal that is switched through a FET to simply open the valve, and then when the valve is closed, we have a flyback diode to protect the FET and dissipate that inrush of current.
This is the cooling stage. This was also one of our unique designs because it is gravity flow instead of controlled by a pump. This was actually reverse engineered from how automated home brewing is typically done, where they put the cooling stage in a boiling environment and run cold water through the copper coil. Ours, the boiling wort actually runs through the copper coil, which is inside this cooling environment. And so the ratio, we have about 26 feet of copper coil, which provides enough time in the cooling environment to get it down to a temperature that it needs to be in the fermentation stage.
This is our fermentation stage. It's basically just a bucket with a temperature sensor and a heating blanket. It's unique to most designs because we're actually using a temperature sensor that runs off of TWI, 2-wire interface. For that interface, we actually had to use the slowest possible speed, which is 100 kilohertz instead of 400. We also have about a 1K pull-up resistor, and the main reason for doing that is we have about 10 feet total of wire on the line, and the capacitance on the line really builds up, so you want to try to keep that speed really slow. And it's basically just a bucket. We have the tube coming in, copper tube for measuring the temperature, airlock as needed with brewing, and the fermentation blanket, which turns on and off based on the temperature.
So that was the automated home brewing system. Couple quick hints for future ECE seniors. What I would have to say is keep your design simple. Don't try and get too over ambitious, and add improvements as you gain confidence in your design.
My suggestion would be to ask as many questions as possible and use resources, use outside resources, and usually when you explain what your project is and what you're doing to people, people are actually really helpful and willing to give their time and supplies to help you out.
And for me, I think the thing that was probably most helpful was taking ECE 473, which is microprocessor system design. If you're going to use any microcontrollers at all, that class is a tremendous help. You'll learn everything you need to know, and it'll make things way easier.